Hello, Introduction to Java Programming. In this session, we will see operators part 3, which are the logical and bitwise operators as part of the basic programming constructs. So in the previous session, we have already discussed the operators in the part 1 like arithmetic, relational and assignment. In the part 2, we have discussed about increment and conditional operator. As part of part 3, we are going to discuss logical operators and bitwise operators. So there are three logical operators, so namely AND operator. So two ampersand symbols is AND operator, and two vertical bars are OR operator, and we have a logical NOT operator. This is actually exclamatory symbol. In the same fashion, as part of this bitwise operators, so we have bitwise AND, we call a single ampersand symbol as bitwise and we have bitwise OR. Then we have negation operator. This is also called tilde operator. This is actually kind of a not here. And we have so three separate operators. The first one actually is the left shift operator. The orientation is towards left, so left shift. And we have the right shift operator, and we have one more in right shift, so right shift with zero fill actually. Okay, so these operators we are going to discuss. Okay, so let's begin with logical operators. And or and not operators. So basically, whenever you apply these operators, you are going to get a Boolean result. You are going to get a Boolean result. Okay, so you apply on some expression, and that expression should evaluate to a Boolean. Yeah. Coming to this AND operator, how it works actually. This is a logical AND. Okay, so if you know the truth tables which you have learned in the basic courses of engineering or whatever it is, so we know about the truth table. So there is a truth table for AND as well. Okay, so we have true and false as the inputs. So since we have two inputs, one is true and another is false, which can be considered as 0 and 1 also, which can be considered as true should be 1 actually and false is going to be 0. We can consider like that. Since we have two inputs, we have four possible combinations. Okay, so if we consider true and false now here, so what are the combinations here? It can be false and false, it can be false and true, and it can be true and false, and it can be true and true. So four possible combinations. Now how these are going to get uh, applied? Let's understand in detail. Yeah, so whenever two inputs false and false comes, so the result for the AND operator actually, so we are discussing about the AND operator, the result is going to be false. Okay, other than the last one, so where both the inputs are true, so everything is going to be false only. So only when true and true is true, rest all is actually false. Okay, so whenever we apply AND operator, we can check more than one condition. So by using this logical operators, what actually we can do is we can check more than one condition by saying and etc. So for example, you want to check any given number is divisible by this number and this number and this number. So whenever you have series of things to check, for example, there is a number, let's call 25, whether it is divisible by 2, 3, 5, 10. So now 2 and 3 and 5 and 10. So whenever we are checking more than one condition, we will actually go with them. And we want everything to be true, then we have to go for AND operation. And any one of them is true, then we can go for OR operation, that we will understand here. So this is AND truth table. So whenever two conditions are false and false, then it is false. And at least one of the conditions is false also, then it is false. And only when two conditions are true, then it is true actually. Okay. So as an example, I'm writing something like this. So if some number modulus of 3 equal to 0 and this number modulus of some 7 equal to 0, then I can say this number is divisible. This is divisible by 3 and 7. It's divisible by 3 and 7. So whenever you have this kind of requirement, right? So you can actually go for this AND operator and most useful operator actually. So many of the times you will see this AND operator getting used whenever we are actually taking certain decisions. Okay, so this is about the AND operator. Okay, now let's understand the OR actually. So OR operator is two vertical bars and this is called OR. Okay, and how it will work. So we have true and false, and then what is the result when you say this is OR operator? Okay, so the OR operator will gives you false only when both the inputs are false. If at least one is true, then it is going to be true. At least one is true, it is going to be true. Only when false and false, it is false. Rest all cases, it is going to be true actually. So in this example, I want to check a number whether it is either divisible by 3 or 7. So when I say divisible by 3 or 7, then I can straight away go for this OR operator. Okay, instead of AND, what I do, OR actually, two vertical bars. So n mod 3 equal to 0 or n mod 7 equal to 0. Anything is true, then this statement is going to get executed. Okay, whereas in the AND, both of them must be true, then only this statement is going to get executed. And now anything is true, then it's okay, right? So that's how this AND and OR operators are available in Java. And of course, all the languages have them. C, C++ and Python, it is actually a different way. Okay, so coming to the last one of the logical operators, that is the NOT operator. So what does NOT will do actually? Okay, so when applied on a true, it will become false. And when applied on a false, it is going to become true. So NOT of an expression. So you take an expression that is evaluating either true or false. You apply NOT. If it is true, it will become a false. And if it is false, it will become true actually. Okay, so NOT of some expression. So this expression should evaluate true, either true or false. If it is true, then it is going to be false. If it is false, then it is going to be true actually. So that's how we have three logical operators. So in order to understand, we write a simple code and find whether a given number is divisible by 3 and 7. Okay, so first of all, we require some number. Let's take some number int n actually, and we will take this number automatically generated by math.random. So this program is to find whether a given number is divisible by 3 or 7. So how we are going to 3 and 7 actually, not or 7, 3 and 7. So int n equal to, so I want to generate a number between 1 to 100. So this is the way we can actually generate a random number. So I'm using math.random and I'm multiplying this with 100 so that I will get 0 to 100 and 0 to 99 actually. So math.random into 100 will give me 0 to 99. I'm going to add 1, so it will become 1 to 100. And the number got generated. We can print that number just to understand. Yeah, just print that number. Otherwise, we can say number generated. is equal to this particular n value. And let's check whether it is divisible by 3 and 7. So how to do that? If this number, whatever is there, modulus of 3 is equal to 0 and logical operator. I want checking one more condition. And this number modulus of 7 is equal to 0. Both are true. Both are true. So if this is true and this is true, then this true block is going to get executed. Right? So here I am going to print n, whatever the number is there, right, is divisible by 3 and 7. Okay. Yeah. So if it fails actually, so now I will have the else block. The same thing I can write, just say that it's not divisible by 3 and 7. It's not divisible by 3 and 7 actually. Okay, so I'm checking more than one condition. That's the point we have to understand here. And this is AND operator, and it will give you true only when both are true. If anything, one thing is false, and this else part is going to get executed. So let's test now actually. Yeah, I'm into my terminal here, and the class name is test. So let's see Java C test.java. Compiled successfully, and when I say test, and let's see, yeah, 25 is generated. Number generated is 25. 25 is not divisible by 3 and 7. Of course, none of them will divide it. Okay, both are false in this case. Now let me see again. Number is 61. It's not divisible by 3 and 7. So both are false again here. And 95, it's again a false thing. And 87 is again a false. 94 is again a false. And 42, yeah, we got the right number actually here, which is divisible by 3 as well as 7 actually, right? So all are false cases because both are not true, or at least one is not true. But here this case both are true. That's why we are actually going to get this. Okay, so if you want R actually, you can just mention here the R symbol and it is done. Okay, so this is about the logical operators, and let's move to the bitwise operators. The seventh one and the last one that we are going to discuss as part of the operators is bitwise operators. Yeah, so what are all the bitwise operators we have? So we have AND operator. We have AND operator. This we call as a bitwise AND actually. We use the bitwise notation because bitwise means it operates on bits. Okay, this is a bitwise AND. So what these bitwise operators are for? They operate on bits straight away. They operate on bits, not on numbers actually. They will take that number, and the number actually is represented in some binary form, that is bits, and these bitwise operators will operate on the bits actually. Let's understand. So this will be interesting. And then we have single vertical bar, that is bitwise OR. And then we have the negation symbol. This is also called tilde operator, and this is going to be the bitwise NOT. Okay, also we have other operators which I have not mentioned actually there, and we have bitwise XOR as well. Bitwise XOR, exclusive OR, bitwise XOR operator. And of course we have three shift operators. This one is the left shift, because the orientation is towards the left, right? So you can see the orientation, the arrow is pointing to left, so left shift operator. Then this is the right shift, and we have one more in Java, right shift with zero fill. Otherwise I can also say unsigned right shift. Unsigned right shift, this is sometimes also called right shift with the zero fill. Whenever you shift to the right and you are actually filling with 0, that's the meaning actually. So we will understand that. Okay. So in order to understand the bitwise operators, one should know how a number is represented in binary. So binary is actually with a base 2, right? And base 2 means it has only two values. So we have 0 and 1. We have different number systems, right? Binary number system, decimal number system that we are using with base 10. We have octal number systems with a base 8 and hexadecimal with a base 16 actually. Okay, so computer understands the binary information. So whatever the way you represent, whether it is a decimal, octal, or hexadecimal, finally that has to be converted back to a binary system, and your machine will understand only zeros and ones actually. Okay, so now, so how to represent 10 actually in a binary? Let's understand. So 10 is represented as 1010. So how it is actually? So let me tell you a simple way to understand how the binary numbers are coming up actually. Okay, so 10 is actually in between 8 and 16. So you should know basically the powers actually. Powers of 2. Okay, you should know the powers of 2. Okay, so at least 2 power 10 you should be knowing, so that you can actually represent any number. Okay, so 2 power 10 is 1024. So any number that is between so 0 to 1024 you can represent straight away actually. Okay, so now let's see here. So this is a 2 power 0. The first one is 2 power 0. Okay, so let me actually write the powers as well here. So this is the 2 power 0, and this is 2 power 1, and this is going to be 2 power 2, and this is going to 2 power 3 actually. So this is how the powers, and we have to represent from 2 power 0 actually. So now if you see here, the 1 bit is set. So what is 2 cube? 2 cube is actually 8, right? And this bit is set. Set means the information is available. 1 means information is there, 0 means there is no information, right? And 1 it is available, and it is 2 power 1, right? So 2 power 1 is how much? So 2 power 1 is set, right? So the 2 power 1 is 2. So now just add them. So 8 plus 2 is how much? 10. So this is how you have to do it. Okay, so now let's try for a bigger number. Let's try for a bigger number. So let's say I want to represent 50. So 50 is in between which two powers? So 2 power 5 is 32, and 2 power 6 is 64, right? It is between 32 and 64. Now let's actually make up. So it can be represented with 6 bits actually. So maximum bits required is 6, right? So now you just write the combination 50. You can write like this, right? So 32, okay, plus 16, that is 48, and you have 2, right? So 2. So this is how you can write actually 50 in 2 powers. So that means your 2 power 5 is there, right? So your 2 power 5 is actually there, and you got 2 power 4 is also there, right? This is also there, and 2 cube 8 is not there, and 2 square 4 is not there, and 2 power 1, okay, is there actually. Okay, 2 power 1, that is 2, is there, and 2 power 0 is not there, right? So we are representing like this. When you actually say the powers actually, so this is 2 power 5, and this is 2 power 4, and this is 2 cube, this is 2 square, and 2 power 1, and 2 power 0. But 2 power 0 is not set. What are all set? 2 power 5 is set, so that is 32, and 2 power 4 is set, that is 62, sorry, 16, and you have no 8, no 4, but 2 power 1 is set. So 32 plus 16 plus 2, that is 50 actually. So any number you can actually do if you know the powers, and if you know how to divide between the powers actually. So that is a pre-knowledge that you require to have for understanding these bitwise operators. Now let's actually understand the bitwise AND operator. So how AND operator will work, how this bitwise AND is going to work. So it works on bits, right? So now whenever it is 1, okay, it makes actually AND operator, right? So whenever 1 and 1 are given, so it will give you the output as 1. Okay, and rest all the cases like 1 0 or 0 1 or 0 and 0, it's going to be 0. Like false, 0 means false actually. Okay, this is 0 and this is also a 0. So only your bits are 1 and 1, then it is going to give you 1. Rest all cases it's going to be 0. Just like your logical AND, true and true, then it is going to give you true. The same fashion, your bitwise AND will provide 1 if both the inputs are 1 and 1, else it is going to be 0. Okay, so now let's understand about this particular bitwise OR operator. Bitwise OR, so single vertical bar. And now let's see. If you know the OR operator, you can actually say 1 and 1 and 1 and 0 and 0 and 1, it is going to be 1. Only when your inputs are 0 and 0, it gives you 0. At least one input is 1, the output is going to be 1. That's how this OR works. Right? This is about OR. Okay, only when 0 and 0 are there, then it is 0. Rest all cases, it's actually true. That is 1. So coming to XOR actually. Coming to XOR, this is actually a cap operator. XOR operator is a cap operator. So this is called exclusive OR. So how it works actually, exclusive OR will actually give you 1 if inputs are different. If your inputs are different, and will give you 0 if they are same. 0 if they are same. If the inputs are same, then it gives you 0. If they're different, then it gives you 1. So 1 and 1, it's going to be 0. And 0 and 0 is going to be 0. And if the inputs are different, it is 1. So 1 0, different inputs 1. 0 and 1, this is 1 actually. This is how the XOR gate or XOR operator will work actually. Okay, so yeah, this is about XOR. And this is something to be noted because we don't have a logical operator for XOR, only we have bitwise operator for XOR. Now, how about negation actually? Negation. So negation makes if it is 1, it will make it 0, and if it is 0, it will make 1 actually. Okay, so this is how it is going to work. Okay, so once these things are discussed, I will actually go to the left shift and right shift. Let me actually tell you with some example. So here I have some number, let's say A, which is actually 4. So how 4 is represented? 2 to the power 2 is 4, right? Only 2 power 2 is set. So now I am representing like this. With the 4 bits, I am representing 0, 1, 0, 0, because only 2 power 2 is set. Now my B value is going to be 3. Now how 3 is represented? 2 and 1, right? So now 0, 0, 2 power 1, that is 0, and 2 power 0 is 1 actually, right? So this is 1 and this is 1. So this 2 power 1 bit set and 2 power 0 bit set. So this is 3. Now if I do A and B, so what is the answer I am going to get? A and B. What is the answer I am going to get? So let's actually discuss A and B. So now let's write the output over here actually. Let's write the output over here for this AND operator. Okay, AND equal to, now we have to start from the rightmost actually. So 0 and 1 is how much? 0 and 1 AND operator is 0. And 0, 1 again 0. Right? And here also 1 and 0, it is 0. And 0 and 0 going to be 0. Right? So A and B is going to be 0 for us. The same fashion, system.out.println A or B. So what is the value we are going to get? A vertical or B. What's the value we are going to get? Let's see. Here this is for OR operator, and let's do now from here. Okay, so 0 and 1, because one input is there, so 1. 0 and 1 again, so 1, right? And 1 and 0, so we have 1, right? And finally 0 and 0, so that's going to be a 0 actually. So what is the value we are getting? 0 1 1 1. So 2 power 4, 2 power 2 power 2, 2 power 1 and 2 power 0 all set. So this is going to be 7 actually. It's going to be 7, right? The same fashion, let's see for the XOR. A exclusive OR of B. What's the value? The value is going to be again 7 here, because for this cap operator, how it works, whenever both the inputs are different actually, 0 and 1 is 1, 0 and 1 is 1, right? 1 0 is 1, so only 0 0, because inputs are same, that is 0, so the output is again same. It is 0 1 1 1, because you have dissimilar inputs, right? Dissimilar inputs, it gives you 1, similar inputs, it gives you 0. So this is again 7 actually. In the same fashion, system.out.println, negation of this particular A. So I'm just asking negation of A. So what is the negation of A actually? So A is 4, so you have to negate it actually. Okay, so the formula for this is actually minus A plus 1 actually. Okay, the formula is going to be minus A plus 1. Let's see how it is going to be work. Okay, so let me write actually code over here, and let me have A and B values initially declared. So this is actually a simple example to demonstrate a bitwise operators. Okay, to demo of bitwise operators. Let me have two values which are declared. So int A equal to 4 and int B equal to 3. Okay, that's it. And I just want to have good number of PL statements here. Okay, this statement, I can have good number of PL statements here. So at least 4 I want to write now. Later I will add 3 more. Yeah. So first actually is A or A and B. And the output that we are expecting is actually 0. And later we have A or B. This I'm expecting as 7. And we have seen A cap B, that is XOR. We are expecting this to be 7, because we have discussed that. And here let's check for this actually, so how it is working. And this one we will write actually. So because it's A equal to 4, it should be some negative value, because the values are getting reversed actually. Let's see. Java C test.java and Java test. Sorry. Okay, so now I have renamed this as main, right? So now Java C main.java, Java main. Yeah, now we can actually see here the output 0 7 7, and this is -5. This is -5. So 4 is getting as -5, because the numbers are actually getting altered. So 0 becomes 1 and 1 becomes 0. So and the sign bit 0 also get reversed actually. So 0 will become 1. So 1 is negative value actually. That's why we are getting -5 actually. So it will be like this. So 4 and minus of the formula is going to be something like this. So minus of this value, whatever the number is there, and that plus 1 actually. So you have something like this. So let me actually tell you here. So here it's actually is going to be -5. This is something to be understood. How we are getting that? How we are getting the formula is minus of whatever the value you are taking. Let's say A plus 1. Right? So A is 4 plus 1 is 5, and the sign bit is getting changed because you are changing the values, right? So the last bit is a sign bit actually. That is also getting changed. So 0 to 1. So 0 is positive and 1 is negative. That's why you will get, when you use the negation operator, you are going to get this one actually. So this is nothing but how it is coming. So minus of this particular a plus 1. This is the formula. Okay, so let's understand the other operators here. They are shift operators. Okay, so we have a left shift, we have a right shift, and we have unsigned right shift. Let's understand the left shift. So I'm actually taking the same value a equal to 4, and that is going to be 0 1 0, yeah, 0. So when you give a number, actually it is going to get stored, it's going to get stored in a register. So that register may be 8-bit register, 16-bit, 32-bit, or 64-bit register. As an example, I'm actually taking an 8-bit register so that we can represent good numbers actually. So with 4 bits we can actually represent up to what, right? So you will have 2 power 4, 15 only we can represent, right? So I want to represent some bigger numbers. I require at least 8 bits. So that's why I'm taking 8 bits actually. So how to represent 4 here with 8 bits? This is how is a 4 actually represented in 8 bits. So usually what happens, no, this last bit is there, no, this is the sign bit. Okay, this is the sign bit. Okay, 0 means positive, 1 means negative. So now what these shift operators will say is you can left shift and they say you can right shift. Okay, you can left shift, you can actually shift number of bits also, number of bits. For example, if I left shift, okay, if I left shift 1 bit, what is going to happen? So my value is a. Now I say a left shift by 1 bit. Okay, what is going to happen? So I'm shifting towards the left actually, right? So this is the left side. So from here I am going to left. So when I shift here, what happens, you know, this bit will go off. So I will have only 7 remain, and 1 0 will get added at the right side. So the left value goes off and 1 0 will get added at the right side. So now what happens? Now a value has become 8 actually. So 4 has become 8. Now again I am doing it. I am again doing it. Okay, left shift of 1. Now what happens? Now this is 8, right? Now one more 0 will go off and 0 will get added over here. So now it is becoming 16. Now it is becoming 16. Right? Now again I shift by 1 bit. Okay, then what happens? It will become 32 actually. Right? So the left shift, when we say left shift, doubles the number. Okay, it doubles the number. It is 4 become 8, 8 become 16, like that actually. Okay, so now it is 32 kind of thing actually, right? Because see 0 1 2 3 4 5, so 2 power 5 is set actually. So right, so this is a 5 one, so that is 32. Fine. So that's how the left shift will work. If you left shift a number by 1, it doubles it. Left shift a number by 2 bits, it will actually double and again double. That means number into 2 power n actually. The formula will be your number into, so whatever your number is there, it will become like number into 2 to the power of how many number of bits you are shifting. That is n actually. Okay, 4 into 2 to the power of 2. If you calculate, so it will be 4 into 2 power for 2 is 4 actually. It becomes 16. That means 4 has become 8 and then again doubling that, so it is 16. So 2 cube. So if you left it by 3 bits, it will become actually now 4 into 2 cube, that is 8 actually. 4 into 8 is 32. So that's what actually happened now over here. So that's the formula. Right? This is about the left shift. So what about the right shift? What about the right shift? Okay, you can also right shift a number by number of bits. I am doing first right shift, and now my a value is now how much? It's actually 32 now, right? Now it is 32, right? 4 has become 32. Now I want to right shift 1 bit. What happens when you right shift means you are shifting to the right actually. So this will get affected, right? This goes off. When it is goes off, 0 will get added over here. Now what happened? So 2 power 5 has become 2 power 4. So 32 has become 16. Now you left shift by one more time, this will become 8 actually. Okay, this will become 8. Okay, so then it will become 4. Then it will become 4 actually. So when you right shift, the number will get half. Okay, it will become half of the number. It will become half of the number for 1 bit. So what is the formula? If you want to take the formula, this is a into that number into to the power of minus n. The 2 to the power of minus n. Okay, number into 2 power minus 1. Number into 2 power minus 2. Okay, like that actually. Okay, it is going to get half actually. Okay, so that's what actually is the case for this left shift and right shift. So now what about this particular uh, unsigned right shift? Of course, I have to add one more here. So here we can say 3 symbols actually, right? 3 greater than symbols is unsigned right shift or shift right shift with the 0 fill. What is about this? Okay, so when you actually do this, what is going to happen is always your sign bit is going to get filled with 0. Okay, so for example, it is a negative value for me now. It's a negative value for me. Now when you shift, what happens, always, okay, so always it is going to get filled with 0. So 0 is going to come actually in the place of this particular sign bit. Sign bit is always going to be 0. So when it is 0, that is nothing but unsigned. Okay, so always your number is going to become positive number. Always your number is going to be a positive number actually. That's what the right shift. So with this, let's write simple statements and understand actually. So I have 3 more PL statements over here. So first, what I'm doing, a left shift by 1. Okay, and what I do again, a left shift by 2. So now what happens, a left shift by 1, the 4 will become 8 over here. So that's output we have to expect. And this is going to be 16 then, right? In the same fashion, I will actually have a right shift, a right shift by 1 actually. Here a value is 4, right? A value is 4 because this one I am not assigning to a again, right? So a value is still 4 only here, right? When I take a here, it is still 4 only. So a right shift 1, so then it will become 2 actually. Okay, so even you do a right shift with the 0 fill, so it is going to be 2 only because it's already positive and positive number will come always. Let's check actually by running this code. Javac main.java, and when you see here, now you can see the output and just compare the output here. So left shift by 1, it becoming 8, then 2 bits it becoming 16, then right shift the a value, the 4 has become now 2. Okay, and unsigned right shift also it is 2 because just 0 will get filled. It's already a positive number and positive number is getting replaced with a positive sign, that is 0. Okay, so this is about the operators, all the 7 kinds of operators that we have seen as part of the basic programming constructs, and we have 4 separate videos made on these operators. Firstly, explaining about what is an operator, what is precedence, what is associativity. Okay, and later we have seen about arithmetic, assignment, and relational. Then we have conditional and increment, decrement, and today we have seen about the bitwise operators and logical operators. And this logical operators is just like a grammar for any natural language. And in order to make an expression, the operators are mandatory. Okay, so with this, we will stop here and thank you for the class.